You got the 2.
Now, the other thing that we're going to look at here is something called an average value.
6, 5, 3.
And I'm going to do a little background for this thing to try to help us out. So, back to the concept of area for just a minute. If I have a curve here that does maybe something like that, and I am looking for, maybe call this A, and call this point B. So I'm looking for the area under this curve from A to B. The average value concept here says that there is some C number between here. I don't know, you can call it like right there. And if I evaluate f of C, so then if I draw that shape in there, the part that's here, that's above that average value line, should actually fit in the part that's here. So I'm a little low on this. Wait. Get it to draw up. Probably about there. So this part in shading here matches this part in shading out here. And so it fills in the gap, and that means as an average value, it puts all the pieces below that line, and that would then represent just the rectangle that it creates. So average value is finding that kind of thing. Okay? That's the idea behind this average value concept. We want to look at what the formula looks like now.
So we get into the statement that the endpoint is going to be at the same value.
Not exactly. Let me get this right.
313.
So for this one, average value is 1 over b minus a times the antiderivative from a to b of f of x dx. So it incorporates that definite integral from a to b, but then also incorporates the endpoints, 1 over b minus a. It's called average value of the function. Any questions about that? Okay.
Why would you use that?
Why do we do averages for things anyway?
Grades.
All right, let's talk about something. On this particular date, there is a calculated average temperature value for that date throughout the recorded temperature time. So they have a recorded average temperature value for this particular date. We may or may not actually hit that specific temperature on a given year for that date. Sometimes we'll be there for a moment, sometimes we'll pretty much stay steady state and be about that temperature all the time. Other times we'll be way above that temperature for the whole day's temperature, and we might be below that temperature for the whole day's temperature. But what we're saying when we say an average valued or an average temperature, we're saying consistently over time, this is where it lands. And then we start to use that value to do some calculations with. Would you agree with that? Or do you understand what I'm saying with that?
So it yields f of c.
Yeah.
Okay.
Yeah, that's what it does. Somewhat tied to that is something called the mean value theorem. And when we use the words mean value theorem, what are we talking about?
Average.
Something we did last
Value.
Is it still under average values, or is this another thing?
There's a little bit of difference in how we present it. And not much, but a little bit. Basically, you can look at it and say, well, you know what? All we really did was multiply both sides by b minus a, and then turn around and identify there's that f of c. So instead of having it solve for f of c, we've got just the definite integral is equal to that f of c times the b minus a. Mean value theorem. So yes, it's very much tied to the average value. They're very similar. A little bit difference in how we present them.
So what is this theorem's relationship to the other theorems?
That.
What did we just do?
I just wrote in FFC there. Okay.
Oh.
So really all we're saying is this one's solving for that FFC number.
And the
Where-
other one is solving for...
The definite integral. And that's the only difference. So they're very much tied to each other. And what you're finding is they're both looking at this concept of how do I find this location that is this average value, that is this rectangle of values that match up. So we need to understand that when we hear the word average of something, things are above and below it potentially, but this is where over time it shows up. Any other good questions about this stuff? Yeah, we can do this.
We can do it.
Yeah, we can. Let's do this.
We should go... So I just wrote it next one.
That'd be awesome.
Except for it was like that.
It's still awesome.
This is part of the tiny amount we did, because we... Did we even go to those one? We were going to, but we...
Okay. Let's use that. Let's find the average value of the function f of x equals 3 e to the x minus 4x for x in the interval from 0 to 1.
Okay. Alright. We can do this. Yeah. Let's do this for something.
So it's just going to be the integral equals f of c because 1 minus 0 is 1.
I agree with that. Let's go ahead and make sure we include that.
Okay. Okay.
So what is the...
One.
Yeah, this is just 1. I probably should have picked another number out there, but that's fine. What is this definite integral value?
How did you get it from the 0? Oh, never mind.
Minus 0
Okay. Do we agree with that part? Anybody have a question about that part? Okay, so now I go ahead and evaluate it with 1, then evaluate it with 0, and I end up with 3e minus 2 minus 3 times 1 plus 0. Do you understand where those numbers showed up from? Or do I need to explain a little bit more about where I gathered those numbers? Okay? So I go ahead and plug the 1 in here, and so e to the 1 is just e, that's why the first part's 3e. And then I plug the 1 in here, 1 squared is 1 times 2, that's the minus 2. And then we subtract, plugging in the 0. So e to the 0 we know to be 1. And then 2 times 0 squared is just 0, but I change that because I'm subtracting the whole value, makes that a plus instead of a minus. But just plugging in each one of those numbers and evaluating. Now we simplify a little bit. We have like 3e minus 5. If I wanted to be a little more particular about this and to say, what is a decimal approximation at the 2 decimal places, we could obviously plug that into our calculators, figure out what that decimal number is, and that's the y value, that is the average value for that function between 0 and 1. Yes, sir?
So if the numbers before the 1 over 1 minus 0, if that was an actual number, like other than 1, you multiply it to the final answer?
Exactly. If I had chosen to make this from 0 to 2 instead of 0 to 1, then it becomes 1/2. And so I'd have a 1/2 times whatever that answer becomes. Yes? Other questions?
What's the thing in front supposed to do? You gave an example.
It averages the endpoints.
Well, yeah, but what would it be if it was, say, on a range of 0 to 3?
Let's do that.
Or not 0, 1 to 3.
Okay. We can do that. If we do that, then obviously a couple of these things change. So this becomes 3 minus 1 from 1 to 3. This now becomes 1/2 times from 1 to 3. And we plug in the 3, and we end up with 1/2 times 3e cubed minus, well, 3 squared is 9 times 2. Is that 18?
Yep.
Okay. And then we plug 1 in here, minus 3e, and it becomes plus 2. Because we have the 1 that goes in there and makes that fit.
Oh.
So you just simplify and take it up a half.